Potassium has three naturally occurring isotopes, potassium 39, potassium 40, and 41. We're given the relative abundance of all three, and we're given the isotopic mass of all three. Problem is asking us to calculate the relative atomic weight of the element potassium. Problem similar to what I did with carbon in class, except here we have three isotopes instead of two with carbon. Again, we're going to calculate a weighted average where we're going to just multiply the isotopic mass times the relative abundance for each of the three isotopes and then add them together. So let's get started in setting up the problem. We'll just go in order with potassium 39. We have an isotopic mass of 38.964 atomic mass units. And we're going to multiply that by the decimal equivalent of the percent abundance, which is going to be 0.9326. Then we're going to add to that the contribution from the potassium 40 isotope. Its atomic mass is 39.964 atomic mass units. And we're going to multiply it by its relative abundance, 0.01000. And then we're going to have the third isotope, so I'll carry it down here. I'll give myself a little bit room for the multiplication step. And our third isotope is the potassium 41 isotope. Its isotopic mass is 40.962 atomic mass units. And we're going to multiply that by its relative abundance as a decimal, 0.06730. Okay, and then we're going to add these three up now after we multiply, and we're going to have to keep track of our significant figures. So let's go through multiplying the first two. We've got 5 significant figures, 4 significant figures. My answer is going to have 4 significant figures. Doing the math, we get a value of 36.34 atomic mass units. We're going to add to that the product of our second isotope, potassium 40. 5 significant figures in the mass, 4 significant figures in the relative abundance. We're going to have 4 significant figures in the answer. We get 0.3996 atomic mass units. And then we're going to add to that our third isotope, product of 40.962, 5 significant figures, and the 4 significant figures in its relative percent abundance, and we're going to get a value of 2.757 atomic mass units. Let's highlight the three numbers we're interested in now. The mass contribution of potassium 39, the mass contribution of potassium 40, and the mass contribution of potassium 41. We're now going to sum these three isotopes and get the total average mass of the potassium element. So let's set this up as we do for our rules for significant figures. We have 36.34 atomic mass units, and we have 0.3996 atomic mass units, and then finally we have 2.757 atomic mass units. Our rules for significant figures: adding numbers, we're going to round our answer to only 2 decimal places because our least precise number, which is the contribution from the first isotope, has only 2 decimal places. So when we add these two and round to the correct number of decimal places, we get a value of 39.49 atomic mass units.